Hello everyone. In this video we're going to talk about optical character recognition, or OCR, and this video is just meant to be an introduction to it. So we are not going to really go into really the depth of it so much. That can be done in a separate or a couple of separate videos. So here we just want to see what is OCR, learn a few things about it, and at the end, so the video is more useful to you, I'll show you a demo of doing OCR in MATLAB with this built-in function OCR. So what is OCR? OCR means converting printed text, or in general it could also involve handwritten text, into optical characters, into basically pictures, into electronic characters. So that is something that is super useful in lots of different applications. For instance, many of you probably used applications from your banks that you can take a picture of a check and then deposit the money into your account, or you have these devices that read books for you, or you have seen law enforcement, their surveillance cameras are looking at the pictures of license plate for cars, and they recognize the number of that, so they can search it in their database, right, and send the ticket to their houses, right? How are these done? Or when you scan a passport, when you scan, let's say, a receipt, a mail, a business card, a credit card, or anything, how are these done? Because they are extremely useful, as I said, for helping like visually impaired people, for automation and so on. Because when everything is optical and it's just a bunch of digits in the computer, now you can easily store them, you can easily search them, you can easily display them and do lots of things like machine learning tasks on them, right? So how is this done? Well, the first thing is you take a snapshot, you take a picture, right? And now, before you do the major OCR technique on it, you have to do some pre-processing. You have to prepare that image to be used for optical character recognition. And the source for this information is mostly Wikipedia, okay? So these are mostly from Wikipedia, most of this information. And I also have some other sources as well, right? This picture here is from MathWork. This bottom one I made myself, but and these pictures are just Google searches basically. So I don't claim any ownership of any of this material. So what are some of the things you do? The first one is de-skewing. So sometimes you take a picture and that picture is not necessarily a nice picture. It's not aligned. It could be rotated. It could have skew. It could have deformations, right? And that is, some of them is due to lens distortion. Some of them is because the way that you align your camera with the document, the edges are not perfectly parallel. So one of the first thing is, first, if your picture comes like this, you might recognize that, hey, there is this rotation angle here, and I need to rotate this back counterclockwise and make the edges horizontal and vertical. Okay, and that is a task of its own, how to recognize that. The second thing is what we call the speckling, or you might say removing blobs. So if your image has positive and negative spots or smoothing edges, you might get rid of them. And you can do that before you convert it to a black and white image, which you call binarization, or you can do it afterwards. Okay, so the one I'm about to show you is, we did this in MATLAB. This despeckling was done after binarization. So what is binarization? Here you try to convert the image that might be color or grayscale. You might convert it to just blacks and whites, which is the maximum contrast between foreground and the background. And how good you can do the binarization will affect your quality of the results big time, and I'm going to show you. So let's see here. This is the picture of just some dials, right, or a dial pad. And here we apply some threshold, and we made it black and white, so bigger than some value white, less than some value black. And here you see you have some blobs here, right? There are some parts of the picture that they do not contribute anything to any text or so on, right? Especially these small blobs and so on. So one of the things you can do is to get rid of them, okay? So if you want to do that in MATLAB, if you want to binarize it, you can use im to bw command. That will, or image binarize, there is an im binarize command in MATLAB which will do that. And if you want to get rid of these ones, there is this command called bw area open. I talked about all of this in one of my videos under computer vision playlist called binary image operations, okay, in MATLAB. So I talked about all of this, but just so you know. And now that you have a clean image of the characters and letters, now it's the part to what? To apply your OCR recognition steps, okay? So you recognize, hey, there is a digit 2 here, there is a digit 3 here. You draw these bounding boxes around them, as you can see in pale yellow, right? And recognize them, okay? But first, as I said, you have to do some pre-processing. Now, what kind of threshold should I use for binarization? If you use the OCR command in MATLAB, you don't need to do that. It will take care of it. But if you have to do some manual pre-processing, you might want to tune your threshold or use some automatic ones like the OTSU method. I have a video again for this one under my playlist Computer Vision, which the OTSU method automatically decides on the threshold based on the histogram of the light intensities. Okay, so there are methods that find these thresholds a little bit more adaptively instead of just a simple number and trial and error. So other than removing blobs or speckles, you might also need to do line removal. Okay, if there are some lines or something that does not basically is not related to any character, you might want to get rid of that. And that's one of them is basically these guys, probably. Some of these you might want to get rid of, okay? Then whatever is remaining, you are going to try to what? Separates the words and the lines, especially the words. You try to separate them. So you try to come and say, hey, this one is separate from what? This one. You want to separate them based on how they are connected to other white pixels or they are isolated. Okay, so here you might do that. One of the things that MATLAB can do for you is this command called BW label. BW label will find for you the isolated blobs, how many of them they're centered, the number of pixels in them. So that's one of the useful commands in MATLAB, BW label. And now that these blobs of words, characters, and so on are separated, okay, and they are isolated, now you can start doing OCR. Now, another thing is this isolation might mean something else too. Like, for instance, if you have several characters connected because of the image artifacts or because of the way that you thresholded the image, you have to be separating them. Or if there is a single character that is broken into smaller pieces, again, you might need to connect them. So here, if we go down here, right, or look at there, you see here, this ABC, it does not look like 3 separate letters. These are, they look, if you apply the BW label command in MATLAB, it gives you all 3 of them as one single blob, not 3. Or sometimes, because the threshold is too much, you might get this 9 partially basically removed, some portion of it like this, for instance. It might be something like that. Look, you might get something like this, depending on how the picture is taken. So now, although these 2 blobs, there are 2 of them, they both belong to number 9, but you have 2 of them right now. So you have to what? You have to connect these 2 blobs, right? By basically closing operation, and you might use opening operation on these to separate them. So you need to create individual blobs. So here there is a lot of pre-processing involved. Okay, so other operations that I said, you can use im open, you can use im close, And there are lots of these operations that you can do to extract these blobs the best you can. Now that you have these blobs, how would you recognize any character by them? In general, there are two major categories of algorithms. One group is called matrix matching or pixel by pixel comparison. The other one is feature detection, which is feature by feature comparison. And you can also see this in my videos when I talked about template matching or feature matching, right? Let me show you. So this is my playlist image processing, computer vision, and OpenCV. These are those binary operations that I talked about. These are advanced ones, but I have some other ones too, which you can see here. Binarization and morphological operations, right? This one, there are some advanced ones here. I have the OTSU method. I should have the OTSU method here, okay? And a lot of these commands also you can see in MATLAB as well, okay? So lots of these I have in MATLAB, and you can see them in MATLAB, right? Now, let's talk about the template matching. So if you want to compare a part of some image to something else, then you can have template matching or you can have feature matching. For instance, here you can see this cam shift algorithm is mostly pixel matching, okay? So you have a template and you try to track that template. And the other one, if you go, let me show you here, you see this is using surf features. So here you're not comparing pixel by pixel of this dollar bill with this other one. You're extracting some features here called surf, right? The speeded up robust features, and compare feature to feature, okay? So you can do all of that to compare one image with another one right here. So what you have is a bank, a collection, a repository of lots of different characters from different languages, from different fonts, and they are all binary. Or you can binarize them. Maybe in the beginning, when you got those pictures, they are not all binary, but you can binarize them. You also have these blobs that you got from your image, and now you want to compare this 8 versus another 8 that you have in your repository. You want to see if these two match or not. So one way is to look at pixel by pixel in the template and in this character, and so that is called matrix matching. So you see here, as I explained, it's literally pixel by pixel comparison of what you have in your repository, which you might call it a glyph, to the extracted features. Okay, now this is very basic level. It takes a lot of computations, and in order for this to work properly, you need those repository pictures to be correctly isolated from the rest of the image. So these pictures that you compare against, they have to be very clean and nice. And the font size and the font scale of them should be the same. If this 8 is quite bigger than the 8 that you got in the image, or if this 8 is in one font and this other 8 is in another font or something, now that looks like a theta, but if this is in Times New Roman and that one is in Calibri, then you might have completely wrong results. So this is very, very sensitive, this pixel to pixel comparison. If this feature here is not in the middle, right, it's shifted, you have to take care of all of them. Otherwise, pixel by pixel comparison can really produce lots of wrong results. And it's not definitely going to work well when something is handwritten, but it's good only for when they are typed. Because when you are typing, the variations are much less compared to when you're writing it by yourself. So these primary methods of OCR, they were used in the physical devices, like the photocell-based OCR devices, like these guys, mostly, that we used to have. The recent ones are mostly using machine learning and feature matching. But what does feature matching mean here? we detect features, and features could be lots of different things. They could be lines, the direction of lines, they could be circles, closed loops, intersections, and there are lots of different features that we can detect. For instance, if you looked at my video on the Hoff transform, right? You see that with an applying Hoff transform, we can detect lines and circles. We can create histograms for them. Or if you look at this surf features, you see these different surf features. Each one, they have their own histogram to describe them. So not only you detect the feature, you have to describe around the feature as well. So you can compare these feature descriptors or these separate features to each other. So instead of all of these pixels, instead of, let's say, I don't know, 60 by 60, 3600 pixels, you reduce it down to maybe 10 features. So now you're comparing 10 features, again, 10 features. So when it comes to comparison, you reduce the dimensionality, although extracting these features is time consuming. So it doesn't mean these guys are faster than pixel by pixel, but since they are in higher level and notations, which are features, lines and circles and so on, as compared to pixel, they are more efficient, okay? And they are more accurate. So you compare the vector of features for this 8 to the vector of features for this stored 8, and you find that this one is closer to that 8, or maybe this 7, or maybe this 6 or 5. You see which one of these stored numbers, the vectors of that, the vector of features of that, is closer to this 8 that you just detected. And by the way, these methods typically use probabilistic techniques and so on, so they might not at the end, or might not give you a single number. They might give you a confidence with that number, or they give you all the different characters that are close to them with some level of confidence. So it says, hey, this 8, this thing that I detected, I'm 90% confident that it's this digit 8. Maybe I'm, what, 5% thinking that it's 7, maybe 10% for 6, maybe 20% for 5, 20% for 6, and so on. Yes? So they might give you different confidence levels. They might use a softmax function. And many of them, by the way, speaking of softmax, they are using neural networks, okay? So many of them are using neural networks to detect different features out of these. They might use convolution neural networks and use a softmax function, or if they are not using a softmax function and neural networks, and they have all of these guys stored, and it's just a vector by vector comparison, they might use methods like k-nearest neighborhood to give you which one of these they are more confident in, with what level of confidence. So these methods, these second categories of methods, which are more recent, they can detect also handwritten text as well, and they are mostly used in modern OCR software. Now, speaking of software, what kind of famous or well-known software do we know for OCR? Well, there are lots of them, but two very famous ones, if you want to know, one is Tesseract, which is one of the pioneers, has been around for so many years. There are several versions of it, and it got better and better. And it is using a neural network too. And there is also Google Docs OCR. There are more. There are lots more OCR algorithms. Okay, and there is also one in MATLAB that they have implemented, and I'm going to show you that. But there are lots of different OCR software packages. Just wanted to give you two names if you want to look them up. The good thing with this Tesseract is it's free. It used to be copyrighted, and now it's free, and it's relatively accurate. A couple of my students used this in a project in the past, and it was relatively accurate. Okay, now is that it? So we pre-process, we get good binary images. We either do pixel by pixel matching or feature by feature matching, and we might or might not use a neural network. And get what? Get a candidate or a bunch of candidates with confidence. Is that it? Now, yes, but one thing that we might talk about is post-processing. So in order to improve the accuracy of OCR, one of the things you do is when you detect the character, like this, or something, some letter like one of these, or maybe some words. Now let's say it's an entire word, because one of the things many of these OCRs do is not just to detect a character. Many of them will detect what? An entire word for you. Like look here, this example I gonna show you in a minute. Here I gave the background logo of my channel, and I ask it to detect this text and show me. And you see here, this is one sample of that, where it detected the word simple, and you see it perfectly recognizes the word simple. So in the beginning, it did not detect simple. In the beginning, it only detected S, I, M, P, L, and E. And now it goes and say, hey, does it make sense that it is like this? Because maybe the system thinks maybe that is not P, maybe that was a Q, maybe it was not a perfect P. So maybe the system thought it could have been a Q instead of a P. Now it goes and say, hey, this S and that I, it looks to be English, right? These are English alphabet, or it could be German or whatever. In English, in German, in these languages, do I have a word like that? So it goes and looks at all the words in those languages. Do I have this SimQL? No. So that should not be a Q. That should be something else. And what are these other letters that I think is detected blob could be correspond to? It says, well, maybe it wasn't Q, maybe it was P. Now it comes and say, okay, do I have the word simple? Yes, I do. So with a high confidence, I say this is word simple. Yes, so one of the steps in pre-process is post-processing is, now you check your entire detection of characters, you put them next to each other, and check them against the list of words in that language, which we call lexicons, and see whether it belongs to them. If it does, that means you have a higher probability of saying this is the detected word. Another thing is, now it goes to a sentence, it goes to a text. Another thing that MATLAB can do for you, not only it can detect you words, it can detect you an entire sentence or text basically. So now what it does, it's the next level. It says, hey, I see the word free and I see the word education and videos. Do I see these words go together in the text that I'm trained on? Do they go together at high frequency? If yes, then I give it higher probability that these three words are next to each other. Let me give you a better example. So if I say Washington, right? And I see something after that. And this thing after that looks like this. Let me use black. Looks like this. What do you think it would do? It says, okay, that is Washington. This guy might be DC, right? Or it might be DOC, let's say, or DLC, right? Something like that. And what do I think it is? Because it might not do a good job in separating that. So it says, okay, Washington is used with doc or DLC? Probably not. Washington is most of the time is used right next to DC. So I have a better confidence in that, and so I declare that with a higher confidence as what? DC. Okay, so seeing these words next to each other and seeing those characters next to each other to form common words is another set of post-processing that is software do to give you a lot better accuracy. Okay, something like a tesseract, it has a two-pass approach. First, it goes and recognize characters. In the second pass, it tries to what? See if these letters can go together to form common words or common sentences, and it gives you a better accuracy. Okay, so they might not do all the OCR in one step, they do it in several steps. And you see, that's not a simple process. It involves image processing, it involves computer vision techniques, it involves neural networks and machine learning. So when you see some text, you can recognize it. Now, let me show you the MATLAB example here. and I'm gonna allow you to download it. I give you a link. So here I upload, I read that image that I just showed you, this logo of my channel, and now I applied the OCR method to it. By the way, the image does not need to be black and white or grayscale, so you can just basically upload a color image. It will convert it to grayscale and then black and white by itself. And you can either pass it the entire image, or you can pass it a region of interest, ROI. Okay, so here I gave it a region of interest, which is basically only this region from here to here. But as I said, if you want, you can give it the whole image. So here I gave it the region that involves text. So let me show you what happens. You pass to it the OCR of I, and it gives you results. Now this result is a structure. It has a bunch of fields. It has a field that is text, and text are all separate sentences or combination of words. So you see the first one is the first line, the second one is the second line, the next one is the third line, and finally you have what? The last line, right? So it goes to an upper level. For each one of those, now it detects characters for you with some confidence and the boxes. So you see, for 126 character, it recognizes. Each one have their each one has their own its own confidence level. Then it combined these characters to find words. It detected 15 words. Each word has a confidence level and a bounding box, and a bunch of other things like the text bounding box, the text confidence, and so on. So you see, you have 3 levels: character, words, and text. And here I want to focus on words. So I say I goes from 1 to the length of results.words. So go to all of the words. Now, if this word is empty, so this means what? No characters in the word. If that word is empty, it's just no characters detected in it, then what? Then don't show it. Okay, so here I'm comparing the characters in that word to W space, which is white space. It gives me a logical vector when I do it with isstr prop. If they are all basically 0, that means none of the characters are white space, because one of the things this OCR does, it separates the words. So in this word, there is no white space. And if that word does not have any white space, so no white space in the word, then what? Then it gets that word and it gets the bounding box of it, and then it overlay it on the top of the image. Okay, so overlay the word on the image. Okay, and that you can do with this insert object annotation, which is a built-in MATLAB function. You pass to it the image and ask it to show the word and put a bounding box around it. What kind of bounding box? A rectangle. Show that image, and then I get the confidence of that word and show it as the title of the image. And I do a pause so we can see the result. So let me run it for you. There we go. You see, it goes over word by word. It shows how much confidence it has in that detection. You see, they're all about 96, 97%. So it did a great job. Okay, and you might say, why did you do that? Why did you use this check whether it has white space or not? Well, actually, it detected one character over here for you. If you look at these words, let me show you. One of these words is an empty character, results, right, dot words. If you look at that, one of them is really empty, and somehow it detected that, and it's right around here. It's right around here. It somehow thought it's a character or a word, but it did not find any word for it, so it returned empty. And I don't want to show that, so that's why I added this logic here. I added this if to get rid of that. Okay, although even I trimmed it, still could find something. And one last thing I want to say is, if your image is low contrast, one of the important thing is this. If your image has low contrast between the words and the foreground and background, basically, or the words and the background, you might not get good results. Look here. So here I give you another version of this image which does not have a good contrast. Look what happens. Nothing was detected. And what is this image? That's this guy here. Look. You see? It was not a black text against white background. It was this blue text against this orange background. And on this guy, it could not detect any single one of these words. Okay, so when you want to have a text for OCR, make sure that the text has a very good contrast with the background. Otherwise, like in this case, you are not going to get any results. Okay, so that is another thing that I wanted to show you, that text must have a high contrast with the background. Okay, so hopefully this simple introduction was useful to you. And again, I let you download this file and upload your own image and play with it and learn how to work with the OCR command in MATLAB. But it's not very complicated, and it doesn't show you any details of how it is doing it. But hopefully you learned some basics about OCR. Thank you, and I'll see you in the next video.